to Unit 8. This is Special Right Triangles and Trigonometry. Open your book to page 5. I want you to take a look at this. At the top, you've got a memory list of perfect squares. Spend some time looking over these. We expect you to be able to recognize the numbers up through 25 squared as perfect squares. To help you with this, we're going to give you a memory quiz on February 4th or 5th, depending on when you have class. So this page is given to you to practice. So after you've studied, cover the top part of the page and do this next set right here. Then look at the top, check it, see which ones you're getting and which ones you're not. Then wait a day or two and come back and then do the second set. Okay, we've given you 2 sets of square roots to practice the same way. So you'll go through, do one set, I would wait a day or so, do the second set. That way you're getting constant practice on this. The next page, page 6, gives you some information about Pythagorean triples. We know that you've already studied the Pythagorean theorem, so we're going to go through it today just pretty quickly, just to touch up a little pieces. But it's really going to be helpful to you if you can recognize your Pythagorean triples. So that's what this page is designed to kind of walk you through. It's not required, but it will make your life a whole lot easier. These families down here, we expect you to be able to recognize. So you can kind of look at how you can use these. So if you have questions on this page, talk to your teacher in class. Okay, now let's go ahead and turn the page over to page 7 and start lesson 8.1. This is about your Pythagorean theorem. Things that you need to remember is that we've got 2 legs of your right triangle and a hypotenuse. You can recognize the hypotenuse because it is across from the right angle. It will also always be the longest side. This side has to be C in your Pythagorean theorem. The legs, you can label A and B, either direction, it doesn't matter. Your Pythagorean theorem simply says that A squared plus B squared equals C squared. We talked about Pythagorean triples just a minute ago, but for example, 3, 4, 5. We call this a Pythagorean triple because when we work this out, 3 squared plus 4 squared would equal 5 squared. So this would be 9 plus 16, and we find out 25 is equal to 25. That means this has to be a Pythagorean triple. It has to give us a right triangle. You want to study page 6 so that you know these Pythagorean triples. Very common, you're going to see 5, 12, 13, 7, 24, 25, and there are more. Okay, so let's do this example here. It says to find the length of the missing leg of a right triangle if the hypotenuse is 20 inches long and the other leg is 8 inches long. Always draw these out. Make sure you're showing where the right angle is. Hypotenuse is 20, so we're going to label that here. This has to be C. One leg is 8 inches. I don't know how long the other one is. I'm just going to call it A. So I have A squared plus 8 squared equals 20 squared. We're going to go work this out, take care of your squares and your arithmetic. And so we get A to be the square root of 336. Do not type that into a calculator and give us a decimal. We do not want to see decimals. We want exact answers. So I'm going to take 336 and I'm simply going to go through and figure this out. This is going to be 168 dividing by 2. We get 84, 2, 21. Now I need to jump to 3, 7. All right, so I have a pair of 2's, and then what I have left, and another pair of 2's. I have 2 pairs of 2's, so that's going to give me a 2 outside, and that's going to give me a 2 outside. So I have 4 on the outside. 3 times 7 times 1 is 21. That would be my answer, and it is in inches. So let's talk about the converse of the Pythagorean theorem. This is what allows us to turn this around and use this in the opposite direction. It says if the sum of the squares of the lengths of two sides of a triangle is equal to the length of the third side, then the triangle is a right triangle. Okay, so the blue is our hypothesis, the green is our conclusion. So we are given the sum of the squares of the lengths of the two sides, so we're just going to write a squared plus b squared, is equal to the length of the third side. So that's my c squared. If we have that, this proves that the triangle is a right triangle. So let's use this to test and find out if the triangles listed below are right triangles. The first thing you need to do is make sure you know which side is C. C is always the longest, so this first one is going to have to be 10. So I'm testing 6 squared plus 8 squared, and I want to know, is that equal to 10 squared? Well, 6 squared is 36, 8 squared is 64, 10 squared is 100. So I do get 100 on both sides, so yes, it is a right triangle. Okay, in the next example, our longest side is the 11, so that has to be our C. So we're going to test 8 squared plus 9 squared, and we want to know, is that equal to 11 squared? So we have 64 and 81, 11 squared is 121. I'm hoping you see at this point how important it is that you know your perfect squares. It makes this so much easier. When we add on the left-hand side, we're going to get 145, and this is not equal to 121. So no, this is not a right triangle. Okay? This last one I want you to try on your own. Your teacher will check when they check your notes to make sure that you did this one. So let's talk about how this helps us. We can use the converse to classify our triangles to determine not just whether or not it's right, but if it's not right, whether it's obtuse or acute. So if a squared plus b squared equals c squared, this is our typical Pythagorean theorem, and we know that the triangle is a right triangle. This works because if I have the two sides here, my hypotenuse exactly matches up. The second one says that if a squared plus b squared is greater than c squared, so let's think about what happens. Here is my a squared and my b squared. If this is bigger than c squared is not going to make it all the way to meet the other side. The only way to make this work is to bring in that third side, making this an acute triangle. And finally, if a squared plus b squared is less than c squared, then we have this situation. Here's my a squared and b squared. C squared is longer than that, so it's going to go past it. The only way to make this work is to take this side and move it out, making my triangle obtuse. When I'm doing these, I like to focus on c squared. It helps me remember which of these two cases we're in. I think of c squared as determining what happens. If c squared is too small, it's acute, like a small angle. If c squared is too big, it's like a big angle, and it would be obtuse. So let's look at these examples. It says to classify the triangle according to the sides. Okay, again, identify C, and so I'm going to test a squared plus b squared, and I'm going to compare that to c squared. So when we add 19 squared plus 20 squared, you're going to get 761. When you calculate 28 squared, you're going to get 784. So my c squared is too big. That makes this an obtuse triangle. Okay, so let's look at the next example. Our longest side has to be c squared, so we're going to do 8 squared plus 24 squared, and we're going to compare that to 25 squared. When we add the values on the left side, you're going to get 689. On the right side, you're going to get 625. Now my c squared is too small, so this is going to be an acute triangle. I want you to try the next two on your own. Again, as with the other examples, your teacher will look for those when they're checking your notes in class. Stop the video. When you've completed these two, resume the video. Pythagorean theorem is very helpful with geometric word problems. When we look at this first example, we need to find the value of y for this point. Well, the value for y is how far above the x-axis that point is. So what we're looking at is a right triangle with a height of y, a hypotenuse of 25. This is your x value, which is -7, but the length of that would be 7. So then we can set this up. Y squared plus 7 squared equals 25 squared. When we do our calculations, we're going to have y squared plus 49 equals 625. Subtract the 49 over, you're going to get 576. And that's a perfect square. Again, it's going to be very helpful to know your perfect squares. If you recognize your Pythagorean triples, this is a 7, 24, 25 Pythagorean triple. So we have the 7 and we have the 25. That means we were missing the 24. So this would be our answer. And if that's the case, you can just write the 7, 24, 25 Pythagorean triple and show that instead of the work to calculate it. But you have to know your triples to use that. So let's look at the next one. Here's a 90-degree angle, which makes this our hypotenuse. Okay, so we have 9 squared plus y squared equals 32 plus 9 squared. 32 is this, 9 is the radius of that circle, so this is also 9. So we're going to have 81 plus y squared equals 41 squared, which is 1,681. That makes my y squared 1,600, and y would be 40. Again, if you're recognizing your Pythagorean triples, you have a 9, 40, 41 Pythagorean triple. That's the side that you were missing. One last problem. This one does not give us a diagram. Hopefully you're well trained enough by this point to realize if they don't give you a diagram, you need to draw it. So we have an equilateral triangle, and the altitude is 6. So that means we need to think about what those two words mean. Equilateral means my sides are all the same length. So I'm going to call all of them x. Altitude goes from the vertex to the opposite side and is perpendicular. So there's my right angle. The altitude has a length of 6. So here's my little right triangle. I know my hypotenuse is x. I know this leg is 6. But this other leg on the bottom, I don't know. So what I need to do is think about how that relates. In an equilateral triangle, these two pieces are going to be congruent. That's going to make this half of x. If you prefer, you can call the half side x and the other side 2x, but we don't tend to see that as easily. And you have to do a little bit of work at the end to figure out the lengths of the side. So I'm just going to go ahead and work with my fraction. So I have 1/2 x squared plus 6 squared equals x squared. When you square that first term, don't forget to square both the fraction and the variable. So we have 1/4 x squared plus 36 equals x squared. When I subtract 1/4 x squared from 1x squared, I'm going to have 3/4 x squared. So 36 would be 3/4 x squared. Now to remove that variable, I'm going to multiply by 4 and divide by 3. So basically I am multiplying by 4/3, or the reciprocal. So when you do your calculations, that's 12 times 4, or 48, is x squared. So x is going to be the square root of 48. Now we need to simplify that because we don't leave radicals in unsimplified form, and we don't give decimals for radicals. So I'm going to take my 48 and just keep dividing by 2 as long as I can. Once I can't divide by 2 anymore, I'm going to divide by 3 until I get to 1. I have a pair of 2's, I have another pair of 2's, That's going to make this 4 radical 3.